Now, our event today, Roadmap to Carbon Zero Homes, is being presented by Jeremy Spencer, one of the godfathers of sustainable design and construction, having had his business Positive Footprints since 2001. While being the director of Positive Footprints, Jeremy's also an energy raider and a builder. His presentation today is proof that sustainable homes are not just a fad, and climate change is not just something that will go away. It is clear that the sooner we act to reduce our carbon footprint, the better for our society and our world. The good news is that we already have the know-how and the technology to produce cost-effective carbon neutral buildings. This webinar is for those who want to know how it can be done, what the big ticket items are, what the benefits are, and what the costs are. Before I hand over to Jeremy, feel free, there's a questions button at the bottom where you can ask us any questions. This presentation will go for around about an hour, and at the end of that hour, we'll have 10 or 15 minutes for some questions. So without further ado, I'll hand over to Jeremy.
Oh, beautiful. Thank you, Simon. I'd just like to, I think I'd just like to start by thanking Simon on behalf of myself and the other founding members, just for having the drive to get this group together. Also thank other Declare groups who've helped get this, this Builders Declare going, particularly Stephen Walsh. Thank you very much. It's an important time for us to get people who are passionate and people who have knowledge and people who want to learn together to start driving the industry in a more sustainable and low carbon direction. So once again, thank you very much, Simon. All right, let me just share my screen. All right, so Simon, I assume you can see that?
All good, Jeremy.
All good, excellent. Okay, good. Look, I just want to start with two facts. The first fact is the construction industry is responsible for 40% of the world's carbon emissions, approximately 40%. This is the broader construction. What does that mean? That means that there is no way that we can get to a low carbon world without the construction industry stepping up and providing leadership and providing a pathway and working out strategies. So that's number one. There is no pathway to a low carbon future that doesn't include the building industry. Okay, number two, Australia has signed the Paris Agreement and it's committed to lowering its carbon emissions by 25% by 2030, which is fantastic. And then moving on to 100% by 2050 or carbon neutral. But 2030 is only 10 years away from now. And in that time, we've got the population set to rise by another 5 million in Australia. And to meet that population demand, it's predicted we're going to need 197,000 homes each year for all those 10 years. So we have a very big challenge in front of us. And we need to start running, we need to start moving, we need to start planning as an industry, and we need to start showing some leadership. And I really thank everyone who's joined up today, because you are the people for whom this is important. And also to actually move in to a low carbon future, we need the different players in the industry to be working together. Builders are super important, but so are designers and town planners and councils and everyone in the mix. Planners, hope I didn't miss anyone. Okay, all important. Let's get on to the roadmap. Let's see if this turns. Okay, so my background is in sustainability, almost 20 years of designing and constructing sustainable homes. Hopefully I'm not a godfather, but anyway. So what I want to present today is a vision of how the domestic construction sector could become carbon neutral reasonably quickly. And I think that this is a really good news story in that we have the technology, we have the know-how, and the price points are all right. And so what I'm going to go through today is a methodology that can be used to get to carbon zero. Now, one thing I should say before I start is that to get there, it doesn't need some fancy ESD magic. It just needs a logical, consistent approach. So it doesn't matter whether you favor passive soil design or passive house, or you want to build with membranes or cross-laminated timber or modular homes. It really doesn't matter. What does matter is whether the builder understands how the house is supposed to achieve its thermal performance and make sure that that is carried out throughout the construction as per specified. Okay, before I get into it, just a little terminology. Operational carbon zero. So there's two bars that I think we should aim for. And the first one is operational carbon zero. And I think it's a very achievable bar. And what I mean by that is that when we're talking homes, what I mean is operational carbon zero is when a home produces as much energy on site and it exports that to the grid as the amount that it draws in. So it may be producing power during the day in excess of what it needs. That power goes out to the grid and goes to the neighbours. And then later on at night time, when there's no sun shining, it'll be drawing power in from the grid. But there's a net balance over the year. That's operational zero. The other type of zero is what I call true carbon zero. And that is operational zero plus looking at the embodied energy of the materials that went into the structure. You know, how many megajoules was in that brick that you just put in? And again, how many megajoules was in the iron bar that went and became a bearer? So I won't be talking about embodied energy today, though I will present it in the roadmap. And I think it's something that we should be aiming for, but I've only got an hour and that's quite a big topic. So I hope to present that a bit, or I hope the Builders Declare will present information on that in the coming months. All right. Now, I'm a firm believer that before you can solve a problem, you have to understand you have to understand the problem. And in this case, what I'm presenting here is a pie graph of the average energy use in a Victorian home. Now, I use Victoria partly because I operate in Victoria. I design and construction businesses in Victoria, so I know the climate well. But also because Victoria has the highest carbon intensity for a house in the whole of Australia at 8.8 tonnes of carbon dioxide a year. And that is when the house uses power and runs appliances to create that power. Of course, they're burning carbon to create carbon dioxide. Across Australia, the average carbon intensity for the average home is 7 tonnes of carbon dioxide per year. So the point being that if we can get a house in Victoria to net zero, then you should be able to do it for any other state if you're in any other state. And also, if you're interested, all this data that I'm talking about has come from the residential baseline study that the government has done. It's fantastic and very interesting document if you're interested in this area, publicly available. Okay, so when you look at the wedge here, or look at the pie here, you can see the wedges are broken down into space conditioning is by far for Victoria the biggest wedge. You'll find that for other states that varies a fair bit. Water heating, it's about a quarter of this pie. Appliances, a bit smaller than a quarter. Then you've got cooking and lighting, small wedges in there. This whole pie also represents a combined gas and electricity bill of $2,686. So if you got your gas bill and your electricity bill for the year, and most homes in Victoria are dual fuel, put them together, the average house would have $2,686. Now, the next point I make, the 6,889 megajoules per year, that's the average energy use that this pie represents, but I've broken it down into kilowatt hours per day. And I've done that because later on I give a couple of examples of some all electric homes that are very close to carbon neutral, and really just so that you can compare what the average is if you converted your gas bill to kilowatts and added it to your electric bill. It would be 52 kilowatt hours a day. So just remember that number for later. And this pie represents the average home size, which is around about 200 square meters. All right, let's get into it. The secret to carbon zero. Now, prepare to be a little bit underwhelmed, but here we go. So the roadmap to sustainability is nothing fancy. It is simply looking at each one of those wedges that was just on the last screen and minimizing them. So minimize space conditioning requirements, that's heating and cooling. Minimize hot water energy, minimize lighting energy, minimize cooking energy, minimize your appliance energy. And then minimize embodied energy if you want to go to true net zero. Once you've done that, you offset with PV. And if you'll see when we do this process that you can get the energy requirements down so low that it is reasonably easy and cost effective to offset it with PV. And the last step I have here is use 100% green power. And that's really just a mopping up process. Just in case you didn't quite put on the right number of panels to get to carbon zero, well, you'll be using such a small amount of energy, or the house will be using so much a small amount of energy that it won't cost very much to go 100% green power. All right, so what's possible? There's the same pie for Victoria. We split it up. So I'm going to look at each segment in turn to find out what's possible within each of these pies here. All right, so minimize space conditioning. That is the first step on the roadmap. And for Victoria, this is a huge wedge of pie. 60% of our energy use just goes to heating and cooling, and the vast amount of that goes to heating in Victoria. And 5.2 tonnes this segment is worth, and we pay $1,600 to supply that much energy. Okay, that's what we're sort of playing for here. Move on. All right, so the first step is just to build to meet the star rating. So if you build a 6-star home and you build it reasonably tight, you put in the insulation as specified, you make sure gaps and cracks are filled, you are reasonably, well, you make sure you go and you tape the foils around the outside in a standard construction, tape them to each other, tape them to the base plate and top plate and to the windows and the walls, seal any gaps and cracks, any penetrations that have been put through, a tape back. That will be enough. If you follow the specifications on the plans and the energy rating, that should be enough to achieve the NatHERS Energy Star. Now, I know that some states, most states use the NatHERS system. I think New South Wales, you'll be on basics. But the point here is build in such a way that you at least achieve the star rating of the plans. And all new homes have to have star ratings and major renovations as well. And it makes a huge difference. 6 stars, just under 50% saving of this wedge already. 7 stars, almost 2/3. 8 stars, bigger than 2/3. 9 stars, almost a tenth there. And 10 stars is hardly anything at all. You almost don't need any mechanical and heating and cooling there. So one thing I would like to point out here though, is that size does matter. If you've got a bigger house, what happens is that the size of your wedge just expands. And so if you're, instead of 200 square meter house, if you're a 400 square meter house or a 40 square house, you would be using twice as much energy as a 200 square meter 6-star house. So if you do have a big house, I would just say that's when it's important that you start looking for the 8 stars, 9 stars, potentially even 10 stars before we start this process. All right, and to try and get as much of this pie as you can. Now, I've highlighted 7 stars here, and I've highlighted it for a reason. The National Construction Code is looking at raising the bar to 7 stars. The Green Building Council of Australia, sorry, is also looking at 7 stars. I know Sustainability Victoria has a carbon zero plan based around 7 stars. So 7 stars is something that we are looking to, or that the industry is starting to look to as a benchmark for getting to carbon zero. And I think it's perfectly realistic. It's not particularly hard to achieve for a designer. 7 stars is pretty easy. Really, any designer should be able to do it. And it's pretty cost effective to get there. So what I'm going to do is I'm going to use 7 stars for the rest of the example and continue through and just see how we can keep minimizing the pie here. Okay. So the next step of reducing this wedge, now that we've got the required heating and cooling down, is to use efficient technology. And I'm talking about heat pumps, also known as heat shifters. And when I started, you know, back in the early 2000s doing sustainable homes, an air conditioner was a big no-no for the sustainable movement. But things have turned around 180 degrees completely, and the technology of these has come on, and now they are super efficient at what they do. Now, why are they efficient? And why are they more efficient than other options? I should just say, by the way, we use a lot of these wall split systems. You don't necessarily have to do that. You can get ducted reverse cycle systems. We've also put in hydronic heat pump systems as well. They only provide heat, but in Victoria, that's pretty much mostly what you need. So you don't have to go for this, but as long as it's some sort of heat pump, it should be very efficient. And you'll notice here I've got this COP and EER greater than 3. Those are the numbers you need to look for. COP stands for coefficient of performance, and that's for heating in the unit. EER stands for energy efficiency ratio, and that's just for the cooling of the unit. But what this means, see, I'll go back one step. When if a gas ducted system, the most efficient a gas ducted system can ever get to is 100% efficient. That's if it's burning in the furnace and 100% of the heat of that goes into the ductwork and 100% of that heat gets into the house. That would be 100% efficient. In practice, of course, it doesn't get there. In the high 90s is good for a ducted gas system. However, these systems, they don't actually make heat and they don't make cool. What they run is a compressor and a loop, a pipe loop where they're piping a gas around, and they're simply grabbing heat from the outside air and bringing inside and dumping it inside. Or if they're in cooling mode, they're grabbing heat from the internal air and they're dumping it outside. And they can, just say it's got a coefficient of performance of 3, what that means is for every 1 kilowatt hour of energy it uses to run this cycle, it's transferring 3 kilowatt hours of energy from the outside and dumping it inside. And you can get coefficients of 3, 4, 5, I think it even goes up to 6 on the Daikin US7. So really super efficient. And effectively what that means is if you put on some sort of heat pump heating and cooling, you can provide this wedge of heating that's required with, in this case, 1/3 of the power. So there we go. And look, straight away, we've knocked off half, or just over half of the whole energy load of a house in these 2 steps, just building to the star rating of 7 stars and putting on efficient heating. Okay, let's have a look at the paybacks here and what's going on. So we've saved 4.4 tonnes of carbon dioxide. And off that bill of 2,686 or 68, we've saved $1,300 approximately per year. So big savings. And what did it cost? So the designer, like I said, 7 bars is a low level for a design to meet. There should be no cost. For a builder, there may be, it depends on the builder, but for us, we have a standard. We'd just put R2.5 in the wall and at least R4 in ceiling. But if you're a builder who's working to minimums and you're working to say an R1.5 in the wall for a 6-star house, and you have to now upgrade to an R2.5. And also if you're not used to taping up the foil properly, which is as per specification, there will be a little bit of cost for you, at least initially until you understand the process. Windows, again, I've got 0 to 8,000. I've got most of my clients coming to me already and wanting double glazing. They want it for soundproofing, and they want it just because double glazed windows tend to be a lot more sturdy and they're a lot more secure, very hard to break in through a double glazed window. Now, if you've got a 6-star home and the only way to get to 7 stars is to double glaze it, well, that would be the worst case scenario. Let's change all the single glazing to double glazing. There's $8,000. But you'll find that most designers really should be able to slightly rejig the house so that you can get to 7 stars with single glazing potentially. If you've got good solar access, maybe low E glazing could get you there too. And that would be a cheaper way. But like I said, a lot of our clients want to go double glazing and it's becoming the industry standard. Heating and cooling system. If you're putting heating and cooling in a home, this is by far the most cost-effective way of doing it anyway. Perhaps if you're doing a very big home, you don't want a lot of split systems everywhere, then reverse cycle would be the way to go. But really, there's not much cost difference. The only cost difference would be is if you only put in a ducted gas heating system, you're not going to put in any cooling system. But really, what the owners will find when they live in a house like that is that come the first summer, they're going to want to put in split systems anyway. So again, I'll put down 0 for that. All right, let's move on. We've done that pie. We've done very well on that pie. And very realistically too, I'd say, on that pie. The next, that piece of pie. The next wedge here is to minimize hot water energy. Next step on the roadmap. Okay, it's worth 18%, which is 1.6 tons of carbon dioxide goes into the energy or is a result of the energy that it provides this hot water, and $480 of your hard-earned cash goes to making the hot water. So how do we minimize this step? Very simply, the first thing is to try and minimize the amount of hot water that we need. And where to focus our effort? So half of the hot water in the house will typically go to the shower. So it makes sense to focus and communicate with the client and tell them that and see if you can get them to go for a low flow shower head. Now, as a builder, what I would suggest you do is you look for efficient appliances, and so that you can have a communication with your client and say, look, I'm trying to get you to this 0 carbon outcome. And I know that appliances and things you put in the house are really important. And I've tried these appliances and these fixtures before, and I think they're value for money. They give me a good shower, yada, yada. Builders have a lot of power during that construction phase of influencing things. So, talk to your client and hopefully you can get them over the line if it's not already specified. Of course, if you're a designer, make sure you specify the shower head. And again, talk to your client and tell them that we're trying to get you to a very low impact home and a very cheap home to run. Washing machines typically will use 1/3 of the hot water. So once again, instead of a top loader, a front loader. And you can choose by these well star ratings as well when you go out. The rest of the fixtures doesn't really matter. Low flow, fantastic. There's not a huge amount to be saved there, but it doesn't hurt to have reasonably low flow. Okay, you do that and straight away you've saved about 1/3 of your hot water needs, right? You just don't need that hot water anymore. Okay, how do we get rid of the next bit or more of this wedge? Well, once again, you look at the water heater that's providing the hot water. So here I've got 2 different options. Once again, we've got a heat pump, that same heat pump technology, but instead of heating air, this time it's heating water. Now, this just happens to be a brand that we use, but there are other brands on the market. They all do a similar thing. Again, you're wanting to look at what their coefficient of performance is. A 4 is better than a 3. A 3 is better than a 2. This one just happens to be somewhere around 4. All right. The other way to go is solar hot water. And with a solar hot water system, you'll be getting 3/4 of your power, of your hot water from the sun, with a good system. So that would be another optional way of providing this amount of hot water, but with a lot less energy. Okay. If you do either of those methods, you can quite easily save another 2/3 of that leftover bit of wedge. And straight away, you can see we've saved a huge amount of this wedge up in the right-hand corner. What have we saved? 1.3 tons of carbon dioxide, $400 approximately in energy. Again, money in your pocket. And what are the costs of these systems. All right. You do have to pay extra for them over your standard hottie. So to go from, say, an instantaneous gas booster to a heat pump, you're looking at about $2,900 extra. To go for a solar hot water, you're looking somewhere between $4,000 and $5,000 if it's a large system with a booster of some sort on it. Typically more our clients are going towards the all electric home, and so we're putting in the heat pump. In the past, we've put in a lot of solar hot waters too. They're both really good products. But if you look at the payback, $400 a year saved, $2,900, you know, you'll pay that back in 7 to 8 years. The solar hot water, you know, maybe you're looking at 10 years, and it'd be quicker than that if you've got a big family. So just bear that in mind. But once again, once they're paid back, fantastic. It's all just, you know, money in your pocket instead. And of course, from day one, you're saving the carbon impact. Okay, so you see how we're working our way around this pie in just a logical, straightforward fashion. There's no gimmickry, there's no special passive solar knowledge that is needed, right? Next one is lighting. Now, lighting is only a small wedge, but it's a really easy one to get. Basically, you can get it by, well, first, you can get it by going to LEDs. I'll cut a long story short there. But while I'm on the screen, I just want to show you, downlights are something to try and be avoided. But this is more from trying to keep the home nice and tight and well insulated. Because every time you cut a hole in the plaster, in most conventionally built homes, the plaster is part of the tightness membrane, even if people don't realize it. And every time you cut a hole, you're introducing a breeze path that can, you know, if the wind's blowing over the top of the house, it'll just be sucking air out. Now, the other thing is often with downlights, you have to remove the insulation around them. If you must have downlights, make sure that you choose a downlight with an IC rating, IC or ICF rating. And that just means that you can actually butt the insulation right up to them. At least your insulation isn't compromised, but you still have air loss through them unless you cork them all, which is a bit of an ordeal. Instead, go for lights that hang into the room. You need much less than because they are allowed to spread in 360 degrees. And if you do that, it's quite easy, you know, to get approximately 40% saving on that little bit of wedge. So we've saved 1.4 tons of carbon dioxide, $40 saved. And really, I've written here that it's either a saving or cost neutral. It really depends on the lights that you buy. But I know which would be cheaper if I was doing as many downlights as in the last picture versus a few pendant lights. Definitely the pendant lights. You save on the electrician's labor there. All right, let's go to the next wedge and see what we can do. Minimize cooking energy. Now, this is often one that some owners can find this a little bit hard to get across the bar because a lot of people like the idea of cooking with gas. And I can understand this, and it's only a small wedge. So if it is the fact that your client really is adamant that they want to go with gas, if you're a builder or designer, or if you're a homeowner and you want to go with gas, it's not a huge bit of the wedge. And later on, when we put on solar panels, it will just be a matter of putting on a bit more to make up for the carbon that you're burning, or the methane and things that are coming off when you're burning the gas there. However, the real value well, I'll go back one step. What can you do, first of all? So I'm suggesting induction cooking. And the reason I'm suggesting this is partly because induction cooking is 50% more energy efficient than gas. You lose a lot of gas around the sides of the pots and the pans that you use. In induction cooking, you don't get that, and it's just a more efficient way of transferring heat. But the real benefit of this is in the fact that, assuming that you have used electric heat pump for heating of the air, heating and cooling, and electric for the hot water, this is really the last gas appliance in the household. And if you get rid of this gas appliance, you can get rid of gas completely, which means that you save on the meter charge, on the connection charge, which is approximately $1 a day. So you're going to save about $300 every year, you know, for the life of the house if you want, in not having gas. It's also, for a new home, it's a lot cheaper to run, an electrical circuit to power this than it is to run a gas pipe for the plumber. So something to bear in mind there. All right, and if you do induction cooking, you get almost 50% saving. Of course, you don't get 50% because there's still a microwave. You still got your oven. So there are other things that use energy in the kitchen. And what have we saved? 0.8 tonnes of carbon dioxide, $25 a year off your energy bill. And I put down here 300 saved from no gas supply charges. All right, that's really the big one, I think. And what is the cost? Well, look, I've done a lot of Google searching on costs of things, and there's really not much correlation now between a cooktop and the cost. You can have expensive gas cooktops or cheap gas cooktops, and expensive inductions and cheap inductions. So the price is much more comparable now. So I would definitely, if you're a homeowner and you're thinking of, of building, but you're not sure about, can I go induction cooking? Give it a try. See if you like it. I think you might be surprised. Installation costs. So I've put down here, it's either zero. The only reason I put $1,000 is if you're doing a renovation and you've already got a gas supply running to the approximately right location of the kitchen, well, then you're not saving in not having to run, a gas line because you've already got one. And it might be the case, depending on the size of the house and the amount of electrical appliances, you might have to upgrade your meter once you go all electric to a 3-phase meter. And in that case, there will be the cost of the upgrade of the meter. So that's why I put the $1,000 in there. It really depends on circumstances, what you need to pay there. The good thing is though, if you do upgrade to a 3-phase meter, you can put on more solar than you can with a single phase. So bear that in mind. All right, the last bit of pie. So worked our way around to appliances. Now, I understand completely, as a builder, you might get plans and it doesn't say what the appliances are, or it says provided by owner. And it can be very disappointing if the owner comes back with, a 2-star bargain that they found at the local shop. Because that's going to reflect badly on their energy bills and they're going to be paying for it later. And really, like I was saying, a lot of this is getting everybody on the same page. The homeowner, the designer, the builder, the council, everyone giving the same sort of information and knowing we're trying for an outcome that, meets all the functions, obviously, but is also low energy. We're going for carbon neutrality. And so what I would do as a builder or as a designer, run a design and construction company, I would recommend that before my owners go shopping, and a lot of owners want to pick their own stuff. So again, have your own suggestions, suggest them to the client, but if the clients want to pick their own stuff, send them to this website, fantastic website, energyrating.gov.au. This is a program that the government has set up which controls the stars and the energy performance of different appliances. And the secret part of this website is this part, the search registration database. There's the address if you want to go to it. But on that search registration, you can choose your appliance. In this case, I've chosen refrigerator, freezer. And you can search by size, and then you can search by type, double door, single door, freezer at top, freezer at bottom, and then you can rank by energy efficiency. And I'd always suggest owners just have a look at these tables before they go shopping so that you know what is best performance in class, and you can check it out. Is it a good price? Is it not a good price? And with these appliances and with choosing stars, we don't need the clients to get the most efficient thing. You'll find that as long as you're not the worst and you're somewhere near the top, that's good enough. So there's a lot of latitude there to shop around and choose something that's on sale. All right, so what can we achieve if our clients actually went off and they were choosing things and part of what they're choosing on was the star rating? What could we assume? We can assume about 30% saving. Now, it's not greater than that because white goods is not the only thing in the house. We've also got consoles, we've got, chargers, phone chargers, bits and bobs that go in the house over time. So but it's still 30% saving, 30, 40% you can just by making good choices. And here we go. What have we saved? 0.46 tons, or almost half a ton of carbon dioxide. That's a lot in the gas, right? $140 saved per year off the bill. And costs, once again, doing a Google search, I couldn't find much correlation between the energy rating and the costs, even within the same brand line. So yeah, hunt around. Choice magazine would be another one that I would recommend clients go and have a look at before they go purchase things. It's nothing worse than buying a dud appliance, and that's definitely not environmental if you have to throw it out and buy another one. All right. So what's possible? Here is the same pie, but you can see all the savings that we've made. So the whole thing, of course, was 52 kilowatt hours. The whole thing was 8.8 tonnes per year. The whole bill, 2,686. Now, if you push that all together, it makes it easier to see what you've saved. You've saved over 2/3, going for 3/4 just on energy efficiency. Now, that is huge. If you're wanting to go to a low carbon economy, look at what we can do in domestic homes just in efficiency, and that is not losing function. You've still got all the same functions. All right, let's look at this table quickly. 8.8 tonnes and 2,686. That was your average standard home. Now this home, 2.4 tonnes, $950. So at least a 2/3 saving on both of those. The last piece of the puzzle is to put on enough panels on the roof to offset that. This is actually a picture of the first house. They sent me their bills and said, look, we're producing way more power than we're using. I was super proud of that. What's a little bit difficult for me though was that on this house we still had gas, so it was it's difficult. I wasn't able to get the gas bill and compare overall, were they producing more power than the combined megajoules of gas and their electricity bill. I suspect they were, because they were so far in front. But that's one of the problems of having dual fuel. It's very hard for a client to monitor that effectively. Okay, so how much do we need? So in my experience, once you have done this, for an average family, and a family just living day by day, 4 persons, you'd expect to probably start from about 5 kilowatts to break even. 4 to 5 kilowatts, you should start to break even. But me, I'd be putting on more now. Look at this. This was, again, just a Google search, and I wouldn't necessarily say always go for the cheapest deal, but wow, what a deal. This is just a no-brainer. You should be getting this. If you can get the rebate, go for it. Even if you can't get the rebate, that price point is a lot less than $1 a watt, and you'll definitely recoup the money spent on that very quickly indeed. So great, do all those things, operational zero. Well done, everyone. Okay, that's the theory. So I want to show you a couple of homes just very quickly. Now, these are 2 homes that are open. Well, when I say open, they're virtually open at Sustainable House Day this year. And I would recommend anyone who is interested to go to sustainablehouseday.com and to check out the homes that are there and see what people are doing these days. Now that the technology is there and the price point has come down, it's super feasible to get to carbon zero. But you look at this house. So this house was a 3-bedroom home, a little over 200 square meters. We were lucky. We've got good northern orientation, so it gets a lot of heating there from the sun. 8.1 stars we were able to get. 4.8 kilowatt system went on the roof. But have a look down here. Their average daily energy consumption, this is over 2 years of 8 quarters of collecting data, 0.6 kilowatt hours per day is their net. 0.6, that's compared to that 52 that I mentioned earlier on. So, to all intents and purposes, this house is just a whisker away from carbon neutral. But, it's a new home. We should be able to do that with new homes, right? But what about renovations? Okay, let's have a look at this one. Oh, I should say, by the way, So who's living in this? Not just one person. There's a couple with their grown son, and they're living in this, living in this house. Okay, here's a renovation that we did. This was an inner city Melbourne renovation. And again, we've managed to achieve 7.9 stars. And we did that partly because the extension out the back, we designed it with some passive solar principles, some good orientation, some good use of mass to pick up the energy falling. Okay, that's fine. The other thing that we did on this job was we insulated the existing house. So like a lot of weatherboards of this era, you'll find that the boards really need replacing. And so what we did is we were going to replace them anyway. We took off those boards. We kept the ones that were actually in good condition, threw out the others, brought in some new ones. But in that process, we were able to re-insulate R2.7 in the walls, put on the reflective foil, tape it up nice and tight. We were able to get underneath the floor and insulate under the floor. And I think we put R4 bats in the ceiling on the existing part. So effectively, these owners had the presence of mind, and through discussion, we made it clear that there was a lot of value to put money into the existing house. And that is, I think, what is often missing in renovation. People often knock off a bit of the back of the house and just go out and not put any money into what they can't see, which is the insulation. We're also able to double glaze the windows here. If you don't invest in the existing structure, what happens is you get a renovation that's performing well, and then an existing structure, which really is just a vampiric drain on the house. So anyway, I would suggest doing that as a process, especially if the cladding needs replacing anyway. Okay, so this house is a family, 4-bedroom home, a couple with 2 children, 2 young children, and they use 3.3 kilowatt hours per day, approximately, is their net consumption. So again, a little bit further away, but so close compared to 52, a huge amount of savings. This is, this is the low carbon economy in real life. And it's something that is achievable. And I definitely think that we can head towards that direction. All right, the last step, like I said, green power. So green power has been a really good thing in the industry. I lost the word there. A really good part of the industry in that it has driven investment into renewables. So every time you sign up to 100% green power, it means that the kilowatts that you use, the provider that you're going with must draw those from renewable sources, wind farms, solar farms, or the like. And once you're down to these sort of levels of performance, the kilowatt hours we're talking about are so small that, it's going to be extremely cost effective to just pay that 5 cents. You won't even notice it. All right. So it's a good way to sort of mop up if you're a little bit short. And all right, let's do a rundown of the whole thing put together. So costs. So the cheapest would be if there's hardly any cost apart from the solar system, maybe the the hot water system, the heat pump hot water system. That'd be around 6,000. If you have to change your windows and do more, you're looking maybe 20,000. But this is the sort of money that you're saving every year, and that gives a payback of 2.5 to 8 years. Worst case scenario. And then after that, well, it's all just money in your pocket. So really, I want to get across, there is no reason why we should not, or clients won't want to go this way. All right. And what do we do for the environment? Okay, 8.8 tons of carbon dioxide per year saved. Assuming the house lasts 75 years, 660 tons. That is significant. That is a huge, that is a big weight. And that's the weight of a gas. Imagine what the volume would be to come up with 660 tons. It is significant. And every time we do a home this way, that's the sort of significance we can have as builders and, professionals in the industry. Forgive me for this unprofessional page, by the way. I was just taken back to my youth as I did this one. All right, so this is the summary page. And I think it's sort of a useful page. I'm happy for anyone to, you know, do a screen capture if they think it's useful for them. I'll just go through it. Minimize space conditioning requirements. So what do we need to do? I would suggest we go for 7 stars as a minimum. Let's aim for that. If you get 6 stars, look, and you do everything else, you're still going to be, you know, you just need to put on a bigger solar system. So it might not be as cost effective for you. Get a builder who is going to build the house well. A poorly built house can take an 8-star home, you know, to become a 2-star home if there's lots of gaps and cracks and air leakages. So you need, whatever system you choose, you need a builder who understands how to get performance out of that system. Choose a heat pump of some sort, whether it's one on the wall like this or a ducted version, hydronic, whatever you can find. Minimize your water use for your hot water appliances. Doesn't really matter about cold water appliances, though that's a good idea. Get some sort of heat pump hot water or solar hot water. LEDs, put them throughout. Try and minimize downlights if you can. Now, if you want to go all electric, go for an induction cooktop. Put one of those on. Then convince your client, if your client is not already on the same page, that look, you put in all this stuff and we're really heading to a really great outcome, and just try and convince them to get on board by choosing appliances that will help with the overall message, what we're trying to achieve here. Now, I'm not talking about embodied energy, but if you do minimize embodied energy, and we'll have a discussion of this somewhere down the track, I would suggest you could offset that potentially by just upscaling your solar system by about 2 kilowatts and just letting those green electrons flood into the grid. And, you know, over 50 years of that happening, or at least 25 years, I guess, for the first system, maybe another 25 for the next system, if you just replace it, you're going to offset all of the energy that went into the house, and effectively that house will be at, you know, true net zero. 5 kilowatt panels on the roof and mop up the rest with green power. And that is pretty much it. I'll be handing back to Simon in a minute, only to say that, you know, everything takes a start. We're a new organisation at Builders Declare, but we are looking for other builders who want to make a difference and want to move the whole building industry in a sustainable direction. And, you know, I think that I've hopefully convinced you that there's a positive message there. And in the future, I know that if you do join up, there will be a lot of sharing of different techniques, different systems that builders have found useful, products they haven't found useful, all that good stuff, to really, for those people who haven't been in the industry a long time, you can leapfrog off the knowledge of others. And that's really what it's all about. It's really about sharing. So I'd like to thank people for listening to my talk today, and I'll hand back to Simon.
Awesome, Jeremy. Thank you very much for that. I think you've certainly proved that it's more than doable. And I think the builders that don't step up to this challenge will get left behind by the industry and by clients wanting, you know, better homes. So we do have a number of questions here, a heap of questions, to be honest. One I'll jump to first was did you create a cavity behind the weatherboard renovation that you showed in that example?
No, I didn't. I just used a breathable membrane on the outside and put weatherboards back on pretty much like they were. You know, it would be even better to create a cavity, but there is obviously a cost to doing that, and you have to also build out the architraves of the windows and so forth to account for the extra thickness in the wall. But you do get a little bit of extra R rating, if you like, from the reflectance of the foil onto a gap. So there is some benefit to it. So a lot of these things, the way that we work, because we do design and construct, and I do energy ratings. So, and what we do is we will do an energy rating in the design phase, and we'll bring clients in and say, this is how the house rates. These are things that you can do to improve it further, and these are the costs. And we will be suggesting things that, you know, that make sense, and then the clients can decide whether they're cost effective. In this case, that wasn't.
Great. I'll start from the top now. Will these slides be available to attendees after the presentation? What do we plan to do with them?
I'm happy to distribute them far and wide. Really, Builders Declare is about getting the message out. And if this can start a conversation, let's do it. Yeah, so what happens there? There should be an email. I'm pretty sure we have the facility to send an email out. Thank you for coming to this talk email. And me and Simon after this might decide how we're going to post the webinar, probably to YouTube. And we'll try and get a link out to everybody. If that fails for some reason, please come back and check the Builders Declare page, and we will put the information on there as to where to find this video. The slides themselves, probably not, but the you know, you can definitely get the video and just freeze frame and capture that way. And perhaps if you need something more, you know, write to me and I'll see what I can do as far as sending you some PDFs.
Yeah, so to reiterate that one, yeah, we will have the video available for anyone that wants to recap over it. Next question. Can you comment on the efficiency and safety of infrared panels?
I'm not quite sure. Oh, are we thinking about the ones that are outside and heating at restaurants and that sort of thing? I'm not quite sure what the question is about. So maybe that person could retype the question and make it a bit more specific.
Okay, Manny, retype that one. All right, Paul's been told by a plumber in the industry that heat pumps for heating are unable to get enough heat from outside air. What's your view on this?
Okay, so it depends on the heat pump, definitely. Unless maybe if you're up in the Alpine, you might start getting problems. In air, even 0 degree air, there is still heat. Unless you go down to negative 273 degrees below zero, which is absolute zero, there is still actually energy in air below our 0 centigrade. And you'll find that all the heat pumps, you should be able to get a graph, and the graph should show what their coefficient of performance is at certain heat, at certain temperatures. So yeah, that's what I would be looking for, and I'd be ringing the manufacturer rather than just trusting the plumber. And if the plumber may very well be right, and in which case you might want to just look around and see what other heat pumps are available.
Cool. Now, Samantha's asked, how many heat pumps would be required to heat the average 200 square metre home?
So we typically put in about 4, and it's not so much how many is required; it's about distribution for the split systems. So if you're doing a ducted reverse cycle system, well, it looks exactly like gas ducted system. You have one big motor on the outside, and you just have vents inside. If you're doing split systems on the wall, well, I'd put, you know, probably a big one in the living area. Another might be firing either in the bedroom or onto a set of bedrooms, maybe one in the master, something like that. You can also get multi-split systems. So instead of having a head unit on the outside and the condenser for every unit and having lots of condensers around the house, you can have one slightly bigger condenser powering 3 or 4 head units inside.
Right. Here's one out of the box from Michelle. How do you find the right builder?
Well, of course, you contact Builders Declare.
That's right. Good.
Yeah. Well, you ask around. I think you know, you can look at Sustainable House Day and talk to owners there. You can look at you can ring Renew. They might have an idea. Actually, Renew, if you haven't checked them out, a fantastic organisation also pushing low energy homes, and they actually have a what they call it, speed dating a designer. So okay, that's designers. We go in there as well. So there's some builders who also get involved in that speed dating.
Yep. Here's one from Jeremy. What options are there if a client can't put solar on their own roof due to too much shading? Hardy's given an answer here, which is creative, I think. Approach your neighbour to contribute to their roof, perhaps start a microgrid. What are your thoughts on that one, Jeremy?
Yeah, I love it. Look, cost effectively, if you're in a very treed area and you can't get solar, and there's no stream nearby so you can get hydro or wind, look, the best you can do is you can still do all the insulation. You can insulate your house well, you can build it to whatever the star rating is that you've got, and really the strategy then is just to build tight and insulate right, and then the plant that you put in to give you the heating and cooling won't have to work too hard to do its job. And then go to green power, and then you'll be effectively carbon zero.
All right, I might grab one more question out from Brendan. What is the benefit of having your own solar panel versus using green energy? I would have thought it would be more cost efficient to build renewable power in bulk. That's a challenging one. What are your thoughts on that?
When you do the sums, it doesn't seem that way. So each kilowatt hour cost for green energy is 5 to 8 cents that you're paying for it, and you just continue to pay for it. And so, whereas with solar, it's one charge up front, and then after every time you produce a kilowatt of power and you use it inside your house, well, that's effectively about 30 cents that you're saving from not having to pull it in from the grid. Or if it was green power, now 35 cents. So the solar on your roof will pay itself off over time, whereas the green power, as good as it is, you're going to have to just keep paying for it forever.
Nailed it. So dollars talk.
Yeah, dollars. I think they're both fantastic for the environment, and they're both good options. Mm-hmm. The only thing that I'll say is that I heard that the green power, its lifetime as a program might run out at 2030. So that's only to bear in mind.
Okay, interesting. All right, we're going to leave it there for our Builders Declare's first presentation. Thank you all again, wherever you are in Australia. Thanks for joining us. Make sure you signed up at Builders Declare Australia. Join us on Facebook, Instagram, and if you're a builder, make sure your tradies are on it as well. Thank you all again, and we'll see you next month.
Thanks, everyone.